Example 2. The same car, the same turn, except the car is accelerating at a rate of 2t meters per second squared. So now let's just say this is the same problem. The car starts at rest and it's accelerating at the rate of 2t meters per second squared. Now what's the difference between the two problems? The one is speeding up at a constant rate, so the acceleration is constant. This one is also speeding up, but at a non-constant rate. Okay? Its tangential acceleration is actually changing. So it's like you getting in the car, pushing the gas pedal, but as you're pushing the gas pedal, you're pushing it harder and harder as you make the turn. Okay? So what's the tangential acceleration in 10 seconds? It's no longer 2. Right? It's now 20. Okay? What's the centripetal acceleration? And here is the trickiest part of the problem. Okay? Here's what a lot of students do at this point. To find the velocity, they say v initial plus at. They start at the same place that we started over there. Then they say v initial is 0. And then over here they put the a. Well, what are they going to put? They put 20 there. And then they put t is 10. They get 200 meters per second for v final. And they're way off. Totally wrong. Okay? About 50% of you will probably make that mistake. 50% of students in general will make that mistake. Because what happens to a lot of you is you use this equation so often that you begin to think that it applies in every case. Okay? When does this apply? Tell me. When? Only if A is constant. Get that in your head. Okay? 50% of you will get that in your head, 50% will not. I assure you. Okay? It only applies if A is constant. So you can't do this to find the final V. How can we get the final V if the A is non-constant? Well, then you have to say AT is equal to 2T, right? Then you have to say AT is dV dt. Then you have to integrate to get the final V. When it's non-constant, you have to integrate. As a matter of fact, where did this equation come from? We integrated the A, and if it's a constant A, its integral is AT. So that equation came by integrating. And so now we got to integrate this. We have V is equal to T squared plus a constant. Okay? And now what's the constant equal to? The constant is whatever the initial velocity of the object was. So in this case, it's 0. Now find the final velocity in 10 seconds. 100 meters per second. It's not 200. Doing that way, you got 200. With this way, it's 100. It's the correct way. And now you take that, you square it, you divide it by r. That's going to be a huge number, huh? It's going to be 4 times 100, 400. The A centripetal is huge. 400 meters per second squared. And now the A total is going to equal square root of 20 squared plus 400 squared. And it's going to be equal to close to 400. And the angle is going to be 20 over 400. So that one is, once you get that, then the rest is easy. So I wanted to show you this because this is where a lot of people get wrong. When they want to find the final V, they always think that this equation always applies, but it doesn't. Okay, good. Next time we'll continue with relative velocity, and then we'll start chapter 5.